All right, so it's chapter 8. It's location planning. Okay. So basically what we have is we're trying to find the best location or better location. So the technique that we're going to use in terms of, quantitative technique are pretty much cost benefit analysis, past cost benefit quantity. It's not only cost and benefit. We have a kind of three-dimensional, so it's not easy to put it on in terms of charts using Excel. I think we should be able to do with pivot chart or pivot table. We try that. If you look at the publisher's template, they have that chart inserted so that you can use the template. But that's, again, only using cost versus volume. So it doesn't show the benefit. The benefit, of course, we can calculate the benefit or profit, but that number was not inserted into template, just in case you're trying to use that template. But anyway, so this is the question number 1. Again, location problem. So we're trying to find a better location from these two cities. Okay, looks like they are trying to build a plant. So which location is better? Okay, simply put. But the factors, the variables we have is just costs and then demand or number of units that you're going to produce. So we have, those numbers available. Then we try to make a decision based on those costs and the quantity. Then we should be able to calculate the profit because we know the cost, we know the volume. Then we can also we can calculate the profit based on those number of quantities. Then we can make a decision on which plant, which location is better. So that's kind of question we're going to get this chapter mostly. And in terms of technique that we can use is just about 3-4 different techniques the textbook uses. But I think we mostly use just based on the costs and the profit in this couple of questions first. So again, so we have costs known, just like here, there's R representing the price for whatever the product they're going to produce. So different prices for different city. And V indicates variable cost per unit so that we can find, how much you're going to produce in terms of profit. And we can find variable cost because each unit is $30, $36 and $47. Okay. Only thing we need to have to calculate is quantity. Quantity is known as well. 8,000 for the Omaha, 12,000 for Kansas City. Okay. And make it better, we have a fixed cost is available too. Okay. One for 1.2 million, the other for $1.4 million. Okay. So all we need to know is what kind of formula we're going to apply. Okay. So I think it's pretty obvious that you need to know the costs, right? Then you need, in terms of fixed cost and the other cost, the variable costs. Again, Q is for quantity, V for the variable costs. So that will be total costs. Okay. So if you know the total cost, if you know the revenue, you'll find the profit, right? So that's pretty much we can manipulate that. In terms of break into different formula, so profit, because profit is total revenue, the price times quantity minus total costs, then we can rewrite this equation here to like that, right? It's just algebraic, arrangement. Just bring this Q as a common factor, then because RQ is there. So R minus, that's come from, what is it? V minus VQ from this part. So that's how, this element is coming from. Then FC is just the same thing from here. So all we did is just arrange the equation from profit, previous one here. And you can still use this one, that's fine. But the reason I did was just probably make it a little bit quicker, depending on, but you can still use this equation. That's fine too. Then if you apply this formula, then you'll find the profit, okay? Because we know the revenue, then we know the costs. Okay. Then based on this, then we found that Kansas City will give you better profit. So again, I'm going to give you this. I'm going to provide those formulas, of course, for the future tests. And the second one, similar, okay, in terms of those variables, in terms of the costs, again, the price and the variable costs. But this time we have a sandwich, okay. This sandwich shop is considering new location, ABC, and those costs and prices are known just like that, and also have a fixed cost for different locations. Then we're trying to find the best solution, best location based on profit. Okay. So what we're trying to do is first we're going to determine monthly volume. Okay, now this time we're going to find the quantity or volume based on the cost and revenue. So assuming we're going to make a $10,000 profit, then how many sandwiches we need to sell? So that's kind of question we have. But we need to rearrange the formula we had before a little bit so that we can find the Q this time, right? The other time we try to find the profit, but we're going to move this Q to the other side so that we can kind of rearrange a little bit. So this is what we got. Just switch profit to quantity and R minus 3 this time to the left, and then profit comes to the other side. Then RV goes to the denominator, and then you have this new formula that we can use to find the volume, or in this case, number of sandwiches. Okay, so profit plus fixed cost over the unit price minus unit costs. Okay, so that'll give you the quantity. And all those numbers are given, so all we do is just plug into this formula, and we'll find location A, 2,400, location B, 2,484, then location C will give you the highest number, so that we can go with location C because it gives us the highest volume for that particular profit. Right? Then this time we're going to calculate profit. So we're going to use the other formula so that we can calculate the profit, which is the same thing, just revenue minus fixed costs, and plug in again, and we'll find the profit for each location. So it looks like a C will give us the highest profit. So we'll go with C as well. All right. And I think one thing those two questions missed is drawing a chart. If you draw the chart, I think it's easier to understand. And if you look at the textbook, I think this is the example the textbook trying to show us. Oops, excuse me. This one, okay. And almost same scenario, only difference is number. We have 4 locations, we have fixed cost for each location, we have variable cost per unit for that location. So the question asked is first plot the total cost for these locations. So we're going to plot the cost versus volume. Okay, so the way we have it here is like that. And to produce this chart, we can use the template from publishers. So let me see, is this the same thing? Compare. Sample. I don't think so. This is example 2. No. Yeah, this is a little different. We have A, B, C, D, right? Yeah, okay. This, we have only A and B. I think this is more like it. And maybe a little different, but point is, all you do is just, let me maximize it a little bit bigger. So using this template, you can enter those fixed costs, okay, for A, B, C, D, variable cost. Then you'll calculate the intersection between, those locations, so that we can find kind of the midpoint for each locations. So that's something we can use it, but this one, we have 4 locations, A, B, C, D, and we're trying, again, this is the cost on the vertical side, and we have the number of unit to produce on the horizontal side. So it doesn't show the profit. So we'll just use those two to determine, which location is best. So that's why we need to look at here, the line which is the lowest, right? Not like this color at the top, which is D. Location D is kind of out of question because it's highest in this example. So we look at this, is this pink color at the bottom, right? And yellow between these 2 points. Looks like from 5,000 to 11,000, right? So that's the next area. Then blue after this point, that will be the, the best option in terms of annual costs. So that's something we can use to inspect the problem by plotting into this chart. Okay. But however, this almost questions didn't ask for a plot, so that's something we can learn from. And question number 3, that's very similar. Okay, this time trying to again relocation for this company. This company is producing some machining tools, some kind of machines, and here's the information. Location A has an annual fixed cost of 800,000 and variable cost for 14,000 per unit. B location has almost 1 million in terms of annual fixed cost, and variable cost is 13,000 per unit. And the price for each unit is $17,000. Okay, this one is a little different, and not just trying to find the profit, but we're trying to find the intersection point for these two locations. So at what volume or at what unit, like it's going to be 100, 200, 300 unit, that those two locations have the same prices, same cost. Okay, so that's why we are using this total cost formula, so that we can kind of set those two formula as an equation and trying to solve for the Q, which is the volume that we trying to find. Okay, so question is again, at what volume of the output will two locations have the same total costs? Okay, so using the formula there, okay, because it's fixed cost plus variable costs. And to find the variable cost, you need to know Q and V. Then you plug in. Then location A is 800,000 plus 14,000 Q. The other one is 920. Then we have 13,000 Q. Again, to be able to find the Q, you need to make it as an equation and set it just like that. Right, then solve for the Q, which is pretty straightforward. Then you come up with 120 if you go through step by step. So meaning that at 120 unit, the total cost for those two locations will be exactly the same. Okay. So next question for that problem is, for what range of output will location A be superior? Same thing for B. So, how many units that location A will be produced to be better? What about location B? How many units will be good for location B? Okay. Again, we found 120. So we know the 120 is the kind of the point, right? That will go above or below. Okay. So if you use it, if you look at the number closely, you'll find it because it's, one has a lower fixed cost, the other one has higher cost. And also we have a variable cost. Or we can plot as the, what we got here. I think I got many charts. I need to know exact number. 800. This template, I think this is the one. Yeah, this is the one. Okay. Okay, so in this template, I use the location analysis worksheets. Okay, the fixed cost is given for A and B variable cost. Okay, then give you a volume that A and B intersect, which is 120, right? Like we just found for solving Q. Okay. Then if you look at this chart, and that's the kind of a little bit unclear because the line is a little bit too thick. But we know that this 120 is right there, right? That's the intersection. Okay. So below 120, we know that A is better, right? And above 120, B is better, right? Based on the chart. So that we can inspect visually. But of course, from the formula, and we can find which is better. All right, so that was the question number 3 in terms of kind of rearranging the formulas we had. Number 4 is not this cost volume thing. It's more of what they call factor ratings. So it's pretty simple. We have weights. Okay, all we have is weights additionally. Then we find the composite score by multiplying by weights. Okay, here's the setup. Again, we have 3 locations, A, B, C, and we have some factors based on the score they're going to give. So they basically, I don't know how they score, maybe from the survey or from the evaluators they have, but they give a score 0 to 100 based on those factors for each location. So they got 80, 70, 60 for convenience, parking, display, shopper traffic for these locations, operating cost, and neighborhood quality. So they have all those scores. And they have weights depending on the importance. Then weight must be, the sum of those weight must be 1, just like 100%. So all you do is just multiplying by weights. But we are not adding across, right? Because there's different location. We are adding vertically. Okay. So location A has those 6 factors. So we multiply those numbers each. Okay, just like that. A, same thing, 1.8 by 88. So you multiply, and then you're going to add them up, and you'll find the composite score for location A. Same thing, B, and multiply by weights, and find the composite score. Location C, same thing, multiply 60 by 0.15, and each step find composite score. Then you compare those scores. So that's what I have here in terms of, calculating those scores. Then you add them up for location A, and again add them up, location B, location C, and then compare which has the highest score. Okay, so it looks like our location A has the high score, so that we can choose location A based on this factor rating. Okay, the weights basically. So I think factor rating is pretty straightforward. At least this question. We can make it factors more complicated, but I don't think you're going to go that far. So, all right. So any questions about those questions?
I do have a question.
Mm-hmm.
The Excel spreadsheet that you're using to fill in yes, those templates, are we able to use that in the test?
If the question asks for this type and need to plot, then I'm going to provide it.
So, okay, so kind of like you've been having us complete like 2 questions in Excel in each of the exams. So are you saying you're not going to really have anything that'll require this level of entry and formulas? So we won't need this?
The template?
The template that you have here, yes.
Well, I don't know yet because we don't have the test yet. So, but I have to think about it, but probably not because we don't have to have the plot for those kind of questions. So probably not.
Okay. Thank you.
Yeah, because I don't have too many stuff that you need to download. So.
Can you go back to question number 1, please?
Sure. Uh-huh. There you go. Yes. Is any
No, thank you. No, I just
particular?
want to.
Oh, okay. You're just looking at it. Okay.
Yeah, I didn't look at it. I wasn't there on time. I apologize.
Oh, okay. Oh, okay. All right. All right. Yeah. We use the this formula, total costs, and we manipulate a little bit here so that we can plug in. But you don't have to manipulate. All you do is just finding total revenue minus total costs.
Thank you.
All right. Any other questions? Well, again, you just, in case you missed it, we're going to have a makeup for those problem-solving questions in case you need to improve your score. So I'm going to send out email with the details. Okay. All right. There's no questions, and we'll see you next time. Okay.
Thank you very much.
All right.
Thank you.
Take care.